Welcome back to part 2 of microwave turns on but won't heat food. Okay, before we get started today, I do want to mention that if you haven't watched part 1, you must go back and watch that first because I cover safety issues extensively in that video, and it's vital that you're aware of those issues before you attempt to work on this microwave. What I also have to do is play the disclaimer, which I'm going to do now. Please note the content of this video is intended for informational purposes only. It is strongly advised that only qualified and experienced individuals who are familiar with working on mains, high voltage devices / appliances should attempt this repair. Failure to do so may result in electric shock and pose a risk to life. Now that we've got the important stuff out the way, let's get back to this repair. Okay, so in part 1, we replaced the high voltage fuse and we also replaced the high voltage diode, as we did some tests on them and we were able to determine that they were both faulty. When we put it all back together and we switched the microwave on and we tried to heat the food did not warm up, or the glass of water did not warm up. And on top of that, when I took the fuse back out and I tested it again, I found that the fuse had blown. Okay, so in this video, what we're going to do is we're going to test 3 other components. We're going to test the high voltage capacitor, we're going to test the magnetron, and we're also going to test the thermal cutout fuses. And I'll explain each one as I go along. The first one that we're going to start with is the high voltage capacitor. So let's do that now. Okay, so we have the high voltage capacitor in front of us now, and we are going to perform 4 tests on it to determine if the capacitor is functioning correctly. If the first 2 tests fail, you do not have to do the other 2 tests. You can just get rid of it at this point and order a replacement. But if the first 2 tests pass, then continue to do the next 2 tests, and you'll be able to determine if it's working or not. So the first test that we're going to do is a very simple test. Okay, we're going to go to the tabs at the top and we're going to test if we have continuity between these 2 tabs. So as you can see, we've got our multimeter in continuity mode, and we are going to go into one of the tabs here. Okay, and we'll get the other end of our lead and we'll go into the second tab here, right? You can see that quite clearly, and you can see that there is no continuity between these 2 tabs, and that is an indication that we are good so far, but we're not finished yet. The next test that you want to do is you want to go from one of the tabs, like I have here, onto the capacitor body, okay, like I'm doing here, and you can see that there is no continuity between that first tab and this body. And I will do the same test again on the second tab. I'm going from the tab to the capacitor body here, and there is no continuity between here and the body. Okay, so it's passed the first 2 tests. The second 2 tests that we're going to do now, I'll just quickly explain to you. The second test that we're going to do is a resistance test. And if you have a look here, right, if I can get that in focus, if you can see here on this diagram here is telling us that there is a 10 mega ohm resistor between the 2 tabs of the capacitor. Okay, and we want to measure to see if we get 10 mega ohms of resistance. Okay, so for the next 2 tests, I'm going to switch over to some alligator leads. It's the exact same thing, just like your multimeter leads, but instead of having needles on the end, you've got like these clips here. Okay, so that'll make it easier to do this next test. Then what we're going to do, we're going to put our multimeter into the 20 mega ohms range, which is just here, as you can see, right? And what we're going to do is we're going to put our black into our COM, and we're going to put our red into here, right? So what we're going to do now is we're going to connect these to our capacitor, and we're going to see what kind of reading we get. So again, connect it into the tabs, one here and one here, and let's see what kind of reading we get. Now, if this works correctly, it should slowly go up to 10 mega ohms. And what we do want to say is that these multimeters here, although they're good enough for general testing, they're not as accurate as the desktop multimeters. And I have actually tested this on the desktop multimeter, and that one goes up to exactly 10 mega ohms. So let's see if this one gets up to it as well. Okay, starting to stabilize a bit more now. I may fast forward this on the video, so just be aware of that. 9.90, 9.91. Okay, so it's stabilized at around 9.92, which is good enough. As I say, I've done this test on the benchtop multimeter, and it does get up to exactly 10 mega ohms. So we can confirm that the resistance is fine. And the next test that we're going to do is the capacitance test. Now, if you have a look here, right, it says here that this capacitor has a rating of 1.20 UF, okay? And we want to measure if that is correct or not, if it does actually get up to that rating. So the way we're going to do that is we're going to do a capacitance test. Okay, so to do the capacitance test, we have to change our multimeter into capacitance mode. And because it's 1.2 UF, we have to take the multimeter into the 100 UF capacitance setting. And we're going to do that now. Now, if you have a look here, it's telling us that, if I turn it slightly this way, it's telling us that we need the leads at the moment are on these 2 points here. And it's telling us you need to change the leads now to these 2 points here. So I'm going to change one of the leads over, and I'm going to put it on here. And now that we're in capacitance mode, all we're going to do is we're going to connect our 2 leads to the 2 tabs. Okay, so let's do that now. And you can see here that it's at 1.1 UF. Okay, now I have measured this on the desktop multimeter as well, and I can confirm that it's exactly 1.2 UF. So we just did 4 tests, and from those 4 tests we were able to determine that our capacitor is functioning correctly. The next thing that we're going to do is we're going to test the magnetron, and we're going to verify if it's functioning correctly. So let's do that now. Okay, so we have the magnetron in front of us here, and the way you take it off is quite simple. You can see these tabs here, one screw here that goes in here, and there's one screw that goes in here. On the other side, there's one screw here and there's one screw here. So you take those 4 screws off, and there is a plug that connects onto the top here. You pull that plug off, you take those 4 screws out, and the magnetron will just come straight out. Okay, so to test the magnetron, what we're going to do is we're going to put our multimeter back into continuity mode, okay? And we're going to test the continuity between these 2 tabs here. On a working magnetron, you should have continuity between these 2 tabs here. So let's do that now. Okay. Now, you can't hear that. You may not be able to hear that because I'll use a compressor and a gate with the microphone, but there is a clear beep that can be heard in the background. So I know that there is continuity between these 2 tabs, and it's past the first test. So let's take that off. Okay. Now, the second test that we need to do is we need to make sure there is no continuity between the first tab and any part of the case. So let's do that now. So we're touching the case here between the first tab and the case, and I can confirm there is no continuity between that tab and this case. Let's test the second tab. There is no continuity between the tab and between any part of this case. So it's passed the first two tests. The next test that we're going to do is we are going to do a resistance test between these two tabs here, and to do that you have to put the multimeter into the 200 ohm setting. Okay, so we're going to go back up there, and you can see here that it's in the 200 ohm setting, and we're going to test the resistance between these 2 points here. And for this test I recommend you switch back to your multimeter leads, because using the alligator clips for the resistance test may give you a higher reading than it actually is. So let's test that now. If this is functioning correctly, we should get a resistance reading below 1 ohm. So let's do that now. And as you can see here, it's reading 0.5 ohms. Now, when I did this test on the benchtop multimeter, which is a lot more accurate, I was getting 0.1 ohms. So as I say, anything below 1 ohms is should be fine. And this information is not from myself. Back in the days when I used to service microwaves, I used to have service manuals, and the manufacturers like LG and GE, they would state that anything below 1 ohms, a reading of below 1 ohms is fine. So far, this Magnetron has passed all those tests. But I want to tell you right now, from experience, from the resistance test, you cannot determine if your Magnetron is faulty. Right? You may pass this resistance test, but your Magnetron still may be faulty. Okay? And what I would recommend then to do in that case is do a visual inspection, and we're going to do that now. So let's move the multimeter out the way. So for the visual test, what we are looking for is any signs of overheating. If you find any signs of overheating, just change out the Magnetron. 95% of the time, that will solve the problem. So let's take a closer look at this Magnetron. Now, if you have a look here, you can clearly see we've got some browning here and also inside here as well, which would indicate that the Magnetron has overheated at some point. Okay, and then if we come around here and we look at the top here, you can clearly see that the discoloration on the front here. Okay, and then if you look inside here, it's almost as if it's burnt inside there. I don't know if you can see that. Okay, so those are 3 inspections that we did, and from experience, I can safely say that this Magnetron is faulty. And what I'm going to do is I'm going to order a replacement. Okay, and I'm going to change it out, and I'm going to see if that's going to solve the problem. But one other thing that we need to test, or 2 other components that we need to test, because this Magnetron has displayed clear evidence of overheating. What I also want to test is the thermal cutout switches, and they are responsible for cutting off the power at a certain temperature to stop the Magnetron from getting destroyed. So let's move over to those, and let's show you what they look like and how to test them. Right, so these here are the thermal cutout switches, and let's have a close look at them to see what they look like. So if you have a look here, they usually have a rating on them. This one says 95N, okay, and the other one here says 145N. And what you'll have one of these on the case of the Magnetron, and you'll have one of them on the the case of the microwave on the inside case. Okay, so if it detects that the temperature is getting too warm on the metal case, this thermal switch here, what it will do, it will disconnect internally, okay, and it will cut out the power to the microwave. And the same again with the magnetron. If this switch here detects too much heat, the temperature that it was designed to get up to, what it will do is it will cut out the connection internally, and it will stop any further power to the microwave, thereby saving, or is supposed to save, the magnetron from getting destroyed. So we need to run some tests on these and make sure they're working. In the normal condition, they would have a connection straight through. Okay, so you'd have continuity between these two tabs here. And when they get up to temperature, they should disconnect themselves internally. So we're going to run two tests to determine that. And we're going to do that now. The first test that we're going to do is we're going to test that they have continuity running through them and they are not stuck in an open state. And to do that, it's very simple. We put our multimeter into continuity mode. We get our two leads and we touch two of the tabs on the thermal cutout switches. So here goes. Now I can confirm there is continuity and there is a clear beep in the room. And this one so far is working fine. And I'm going to test the second one from this tab to this tab, and I can confirm that there is a clear beep and there is clear continuity on this thermal cutout switch as well. Now to do the next test, we're going to move over to a different workbench, and I'll explain to you in detail what we're about to do. Right, let me just take a second to quickly explain to you what's going on here. We have the thermal cutout switch on a hot plate, which is connected to a temperature sensor. The temperature sensor will display the current temperature on the hot plate. And then what we have is we have our multimeter in continuity mode connected to the two tabs of the thermal cutout switch. And what we're going to be observing today is at what temperature the thermal cutout switch disconnects itself internally. Now, this thermal cutout switch is the one that sits on the magnetron. So if you have a look here, we are currently at 108 degrees on the hot plate. And what we're going to do is we're going to switch our multimeter on. And you can clearly see there is continuity between these two tabs. So let's switch the hot plate on. And let's observe at what temperature the switch disconnects itself. Now I may fast forward this on the video, so just be aware of that. I'm expecting this one to disconnect itself around about 150, 160 degrees. Remember, there is a 5% error rate on these, so it may go slightly over. Okay, exactly 170 degrees. The thermal cutout switch has disconnected itself internally. So what we're going to do now is we're going to switch the hot plate off, and we're going to wait for it to cool down, and we're going to observe at what temperature it reconnects itself. And from that, we'll be able to determine that this switch, whether it's working correctly or not. Okay, so I can reconfirm to you now that the thermal cutout switch reconnected itself at 138 degrees. So we know that this switch is functioning correctly. And while we're here, I'll also confirm to you that I ran the same test on the other thermal cutout switch, the one that sits on the inside case. And for this one, the disconnect temperature was 100 degrees, and it reconnected itself at about 80 degrees. So you can get these thermal cutout switches in 100 degree rating and also at 165 degree ratings as well. So that would indicate to me that both of these cutout switches are functioning as intended, and we don't need to worry about them. We can just focus on the magnetron for now. So to locate these magnetrons online, it's quite easy. What you do is you open a Google page, and on the front of your magnetron, you will have an identification number. This one is 2M248J. Okay. And if you type in that identification number, you'll get a whole host of them that will come up. But I want to give you some more information about these magnetrons. Sometimes you will have a separate letter next to this identification number. It might be a A, it might be a Y, and so forth, etc. What that relates to is the screw pattern. So if you have a look at this one is also a 2M248J, but it has a Y on the end, and you can see that the screw pattern is slightly different, or the screw holes are slightly different on this one. The one that we've got, it looks more like this one here. If you can see the screw pattern, it's got 3 screw holes here. So the only important thing is that you need to match up the screw pattern with the type of magnetron that you have, that you're trying to replace. Now, when you're going to buy these, okay, you've got a couple of choices that you can choose from. You can either go for a reconditioned unit, right, which is going to be slightly cheaper, and you can get them off AliExpress, right? And I'll show you an example here. Let's go into this one, for example. If you can see here, the price on this one is $16.59. They're showing you an original one here, a brand new one, but I've ordered from here before, and the ones that they send out are not like, they do not look like this. You can easily tell that they're actually reconditioned units. So I'm just making you aware of that. If you're ordering one of these thinking that you're going to get a brand new unit, it won't be. It will most likely be a reconditioned unit. Now, it costs $16.59. That's before tax, and the shipping is £12.26. And when you add all that up and you add 20% VAT for the UK, or I don't know what it's going to be like in the rest of Europe, the total will come to about £35. So if you want to buy a reconditioned unit, you're looking to pay about £35 for this model. If you don't want to get a reconditioned unit, then you can search for them on Amazon, and you can see here, you can buy a brand new unit here, and they're selling for £54.22. I mean, you can search for these on eBay as well. You can find these new units. You're looking to pay around about £50 to £60 for a new unit. Some places they can be more, so do shop around and try and get the best prices that you can. So I offered the customer the choice. I said, look, we can give you a brand new unit. It's going to cost about £60. Or you can go for a reconditioned one, and that will cost about £35. So he's happy to put a reconditioned unit into this one. That's all there is to it. I've ordered this unit here, 1655 one, reconditioned one, and it's been delivered. I'm going to show you a close up on the desk, and we'll take it from there. So the reconditioned unit has arrived. You can clearly tell it's reconditioned. Well, first of all, you can see there's no burnt. You can see the difference between the other one that we had and how clean this top bit is here. And also, if you have a look inside here, the other one, our original one, was burnt from inside. If you have a look at the fins here, you can see they're quite clean. Now, you can tell it's a reconditioned unit because this spray job is not the original spray job. What they've done is they collect these at the factory. They probably get them back under warranty, and they change out the internals. Right, they'll change out the cap. Probably change out some parts inside here as well. They respray them and they sell them as well. They'll advertise them. They won't say whether they're new or used, but we know from experience these are reconditioned. And some of the telltale signs are, if you have a look here, on the original, the fins here, they were very shiny, okay, but because these ones have been resprayed, they don't have that shine to them like the original, okay. And also, if you have a look here, you can see here that this is clearly not a brand new plug. as it's got some signs of use on it. And then the biggest giveaway is that if you have a look here, this sticker that they've put on is just fake. It says Toshiba, but if you have a close up here, if you have a look at a close up look, you can see here that they've connected, they've spelt the disconnect the electric power. They've spelt disconnect wrong. They've put DISCOOMNECT, and that's not how you spell disconnect. So I'll just compare that to the original, and you can see here. Right. So here's the original, and you can clearly see the differences, right? So if you get one like this, just know that it is a refurbished unit, and there's nothing wrong with that. I've put these refurbished units in microwaves, and people have used them for ages without any issues. I haven't had any returns, so I'm all for reusing stuff if it's going to save money and it's going to save stuff going into the landfill, and it's going to be a bit cheaper as well. But what I would recommend is if you're going to use it in a commercial scenario, then I would recommend you pay a bit more and just go for the original, just for that peace of mind. But these reconditioned units are fine. You can put them in and they'll work just fine as well. But your mileage may vary. I'm just telling you from my experience. Okay, so what I'm going to do now is I'm going to install everything back into the microwave. I'm not going to show that on the video because the video has already gone on for too long, and I've already shown how to take everything out in part 1, and it's just the reverse of taking it out. Putting it back in is the reverse of taking it out. It's exactly the same procedure. So I'm going to do that now, and we'll test the microwave shortly. So we've installed everything back into the microwave, and what we've done is we've put a glass filled with ice and no liquid into the microwave, and if you have a look on the thermal camera, the temperature of the glass is about 15 degrees. Let's just say it's 15 degrees, okay? And what we're going to do now is we're going to close it, and we're going to do a quick 30-second run on it, and we're going to see what happens. Okay, so we'll open that up, and if you have a look here, the temperature has been increased to 21 degrees, right? And if we bring the glass up to the camera, you can see that there's some liquid in the bottom. That means that the ice has warmed up, and the magnetron is working correctly, and the microwave is working correctly as well. Okay, so that was a success. So I did a bit of research online. What I was able to find out was that this microwave, this model that we repaired, it was sold under 2 brand names. It was sold under the Gastrotech brand name and also under the Menu Master brand name. And if you have a look on Amazon's page here, they still have it listed under both brand names. So it's a model that was sold under 2 different brand names, and we can take a closer look here, and you can see it's exactly the same microwave. Now, Amazon are no longer selling this one here, but if we go and do a search on Google, then you can see here that it's still available by other retailers. For example, Nisbets, they are a commercial equipment supplier to the food trade. They're selling it here for £395. Let's have a look here. Who else is selling it? This one here is the same model. It's being sold by a catering centre, and they're selling it for £400 and £64. There's another company here called who are these? Easy Equipment. They're selling it for £593.99. But let's just go by these 2 companies for now. Brand new, you're looking to pay about £400 with duty in the UK. Now what we're going to do is we're going to do a little cost analysis and a little breakdown to see if for you as a repairer or as a repair shop, is it worth taking on repairs like this. And we'll do our own cost analysis, and then you can compare that to what it might cost you in your own shop. So let's do that now. Okay, so here we are with our cost analysis. So for us, because we are a mail-in repair business, the labor for this one, we're going to charge £100. Now, if you were a walk-in repair shop, you could possibly charge £75 or even £80 and get away with that, because you wouldn't have to receive the extra large package, take it all out, repackage it up, book it in, and send it back out. That's extra labor, so we have to take that into account. So we'll charge £100 for the labor. I believe that's quite fair and reasonable. It is a commercial microwave. It's not a consumer type microwave. So we take that into account as well. The Magnetron, the customer chose in this case to have the reconditioned unit, which cost him £35. The high voltage fuse, let's say it's costing us £5. I think it was about £7, but let's just say £5, because if you buy them bulk, you can get them for cheaper. And the high voltage diode, that was about £5 as well. And for them to ship it to us, the customer, I think they spent about £20. And for us to ship it back to them, it's going to cost about £20 as well. So the total cost to the customer is going to be about £185. So a new unit, if it costs £395, then that is a potential saving of £210 off a new unit. So in this case, it's a no-brainer to get the old one repaired. Now, if a microwave costs less than £250, right, and it's a commercial microwave, then I would say maybe in that situation it's worth buying a new one, because you're not going to get a big saving, and you're also going to get a full 12 months warranty with the new one as well. But when you're in this kind of situation and the microwave costs over £300, here they're saving £210 off a new unit, then it's definitely worth considering getting them repaired. So if you're a catering business and you've got a microwave that's suffering with this same issue, this will give you some idea of what we're going to charge you if your Magnetron has failed and the other components listed here have failed as well. And you can easily contact us through the website. Just send us a message, and we'll get back to you shortly to assist you further and tell you about the process, how it works. So that's it really for now. I hope you found this 2-part video series helpful as well. We're going to wrap it up now. As always, bye for now and have a nice day.